Hello and welcome to the Daily Space. I'm your host, Dr. Pamela Gay,
And I am your host, Beth Johnson.
and we are here to put science in your brain.
Over the last year, we've talked a lot about ways scientists are trying to measure both historic and current climate changes. From looking at tree rings in fossilized trees to looking at ice layers in Greenland ice, researchers travel the world looking for old things that record seasonal cycles. In new research appearing in geophysical research letters, researchers led by Dominic Gawinski have looked at the salt deposits left behind by melting sea ice to get new data. Essentially, over the winter, sea ice is blown inland by storms. The more sea ice, the more gets blown inland. When that ice melts, it leaves behind salt in proportion to the amount of sea ice. That salt is then captured in ice cores. According to their paper, ice core data across Antarctica show increasing sea salt concentrations since 11,400 years ago, representing cooling and sea ice expansion, particularly between 8,000 and 10,000 years ago. Between 5,000 and 6,000 years ago, a drop in sea salt indicates an abrupt reduction in sea ice cover in the South Atlantic. Interestingly, paleoclimate data suggest that sea ice was more extensive in the North Atlantic at this time, indicating a linked and opposing sea ice signal in the North and South Atlantic, most likely due to changing ocean circulation. This finding is consistent with models that predict that changes in sea ice and glaciation will fundamentally change ocean currents. To those of you who feel like the last few years have gotten weirder and weirder when it comes to the weather, you are right. We are alive to see our world changing, and scientifically, this is an amazing opportunity. But I think it is an opportunity all of us would happily pass up.
Working on the other side of the world, researchers have been working to recreate the circulation patterns in the North Atlantic, looking to see how and how fast these currents may have changed over time. Specifically, they are looking at the currents responsible for carrying warm water from the tropics up along the coast of Europe and the United Kingdom and moderating the winters there. The historical strength of these currents is reflected in seafloor samples that show what size grains were getting moved and allow the compositions to be measured and traced back through time. The researchers find that major ice melting events weakened these currents. Well, these events were triggered by warming climate, melting glaciers. They also had the effect of cooling northern latitudes and triggering colder winters. This feedback led to wild oscillations in climate, currents, and glaciers over time. This is a reminder that when we talk about climate change, we are looking at the average of what's happening across the entire planet. That zero point 0.5 degree change the planet sees may be a 10-degree increase in one place and an 11-degree decrease in another. As the glaciers melt and the oceans become less salty, ironically, northern Europe and the United Kingdom can expect more colder winters, while the American Southwest and other regions have hotter summers. And those of us in the middle, we see much more extremes. The world, it is a changin'.
Understanding our world requires us to understand the effects of minor changes to our atmosphere that are caused by pollution, volcanoes, and outgassing cows. Since the cows are natural, we're not going to call that pollution, although opinions may vary. We also have to look at the sun and its behaviors. From 1645 to 1715, for instance, the sun went through a weird low period where, with very few sunspots and none of it normal, it's normal every 11-year maxima occurring. This period of solar minima, called the Maunder minimum, coincided with drops in temperature on Earth that dramatically affected harvests. We still don't know what happened, but the need to understand solar activity drives all sorts of research into the sun's magnetic fields. In a new study appearing in Nature Astronomy and led by Marco Stangalini, astronomers use high resolution images of the solar atmosphere to study how magnetically driven waves, called Alfvén waves, carry energy through the sun's atmosphere. Remarkably, They found that waves low down in the atmosphere are able to send energy up through a column of material, potentially even explaining why the sun's outermost layers are hotter than the lower layers. While these waves were predicted 50 years ago, it is only with today's high quality instruments and powerful computer models that we can finally study them in detail. And the still new Inouye Solar Telescope has more and more time to capture data. We can expect more breakthroughs.
While the sun's short term fluctuations rarely affect our Earth at its surface, its periodic outbursts and changes in activity can wildly affect the Earth's outer atmosphere, both by generating amazing aurora and by causing the atmosphere to change in size over time. For low orbiting spacecraft, that change in size is a major issue as even a couple hundred kilometers up, the rare atmospheric particles still create a drag on spacecraft. And that drag will eventually bring those spacecraft down given the chance. Over the past 60 some odd years of launching things into space, researchers have come to notice that when the sun is more active, more stuff is observed to fall out of orbit. And in general, it takes more effort to keep things in orbit. This effect can have dramatic impacts on modeling where and when space junk might fall to Earth and has to be included in long and short term models for objects ranging from decades old dead satellites to recently misplaced Chinese rockets. In a new paper in the Astrophysical Journal Supplements, led by Tatiana Podlyachkova, a new software model is released that should allow solar radioactivity to be predicted on timescales of 1 to 24 months, depending on the kind of activity. This software is called Resonance and should allow mission planners to better understand their fuel needs and how their dead missions will decay back to Earth. We are all a bit excited to see if their 2 year estimates prove true, and I, for one, wish we could do this for more weather related phenomena. After the break, we'll be back to talk about one of the prettiest things in our sky, planetary nebulae. Stay tuned. One of the most confusing and delightful objects in our sky is the planetary nebula. When initially discovered by early telescope builders, these often round blobs of light looked like planets, but failed to wander relative to the stars the way planets do. As telescopes got better and better over the centuries, new details emerged, making these blobs resolve into still hard to see structures that sometimes looked like faces or geometric doodlings. It was eventually understood that these nebulae form in the final stages of a middle sized star's life. When the stars, like our sun, come to an end, they exhale their outer layers and leave behind their core to form a white dwarf star. The shape of the resulting nebula depends on how that star puffs off its atmosphere. Is it a continual process? Does it occur in pulsations? It's also a function of what is around the star. Is there a neighboring star or surrounding planets to block the path of the gas? To put all these pieces together, high quality data is needed to describe the shape and anything else that can be measured. One of the original justifications for the Hubble Space Telescope was to image planetary nebula from above the atmosphere so the smallest possible details could be seen. Over recent decades, Hubble has not disappointed, and its rich catalog of images has brought home to all of us that what is going on is far more complicated than any of us realized from looking at ground based telescope images. With high quality images in hand, folks realized we need more. We needed velocity data to explain to us how every knot and twist of gas is moving. And in a new paper shared on arXiv while undergoing peer review, researchers present data on planetary nebula NGC 1514 and showed that this extraordinarily complex planetary nebula has a binary star system in its center and a morphology that is so far unique and is accompanied by motions they can actually measure. by placing a very thin slit into a telescope's instrumentation. It's possible to spread the light out into a spectra that captures the specific motions, temperatures, and compositions of whatever happens to be located at each point along that slit. By looking at motions at many points throughout the planetary nebula, they were able to piece this object's complexity together. In the data, they found a parallel structure that looks like a barrel, two well-defined rings glowing coolly in infrared light, and temperatures that allow argon, neon, and helium to glow brightly like naturally occurring neon signs. More data is still needed to understand what all this means. More data and also a lot of computer modeling. But this research highlights there is more than one way to probe a planetary nebula, and even the weirdest looking systems have the possibility to be understood. After the break, we have special guest, astronaut and fellow podcaster, Cady Coleman. She'll be joining us to talk about her flight to the International Space Station, her music, and of course, that new podcast she and co-host Andrew Menard are producing in collaboration with Arizona State University and Slate. Stay tuned.
Welcome back. Joining me now is astronaut Cady Coleman. Dr. Coleman is a veteran of 2 space shuttle missions and spent 6 months aboard the International Space Station as a member of Expedition 2627. She is also a member of Bandella, a band that includes several other former astronauts. She plays the flute and has performed with Ian Anderson of Jethro Tull in a space-based duet where she was on the ISS and he was performing at a concert in Russia. Now, with scientist Andrew Menard, she co-hosts the new Slate and Arizona State University podcast, Mission Interplanetary, which looks at the challenges and opportunities for the future of humans in space. Welcome,
Hey.
Dr. Coleman, and thank you for joining us.
Thanks very much. It's really nice to be with you.
Welcome to the podcasting world. That's exciting news. Are you so far enjoying the process?
I am. It's, I think I'm sort of in denial that there's people listening, where you just, it's kind of like when you hate to listen to yourself on a recording, I just like try to just blank that part out. And actually the joy of doing it together, we have a really neat group. Andrew Maynard is my co-host and there's just something we met for breakfast. The producer put us together and I was like, I would love to do something this with this guy because he thinks really differently than I do. And I think together we get interesting things out of our guests. We don't really hold them down or anything.
It's not attack journalism is what you're saying.
Exactly.
So were you and Andrew placed together? I think you said something backstage basically about it being a podcasting blind date. So how did that work?
Well, it starts really at ASU, Arizona State University, where they have their place where you study space and you study Earth is the same, the School of Earth and Space Exploration, which I think to all of us on this show makes a lot of sense. When you're exploring space, you're really exploring Earth as well. And to have all those people together makes a lot of sense. And they also have an interplanetary initiative that has pilot projects that is really just looking at, well, when we become an interplanetary species, what are the things we should be looking at? And of course, the first thing you're going to do if you're really interplanetary is have a podcast, right? In this decade, we're taking, selfies, but, podcasting is next. And so there's a drama professor named Lance Garavi that had this idea and had Andrew and I in mind and asked us to go and eat breakfast together. And I was new at Arizona State. I am their global explorer in residence who doesn't actually live there. But I really love the way they are about education in general. They're very much about the fact that everyone has the right to an education and it doesn't just happen. You have to innovatively make it so. And so it's why I like being associated with them. And so Andrew is actually in the School of Global Futures at Arizona State University. And okay. I don't know, that's how that happened. And I think it's been really, I've just been really happy about the episodes that we've made. And as I'm watching the news and, we'll probably re-release some of them over the summer while we're making season 2, but they still apply. Like,
yeah, I noticed, well, I think it was the most recent one. You were talking with someone from the Smithsonian, and at the beginning of the episode, you talked about how your space junk episode ended up being incredibly timely because of the Chinese the Long March 5B core stage that had to come back to Earth.
Well, and I think it's what on your show. I mean, I've listened to your show too, and I like it, and I like what you explain to people, and I like how you give people kind of the bigger picture and the detailed picture, where it's one thing to focus on one rocket stage, coming back to Earth, and for people to realize that there's a lot of dimensions to this problem that actually we know about, and with our ability to measure more and more finely. We know about 27,000 pieces of stuff in orbit that are 10 centimeters or bigger. Mm-hmm. But the other number that I'm just sure is really much scarier is that there are 500,000 pieces of space debris that are between 1 centimeter and 10. And so to do the math of, and it's really, this is pretty recent. I mean, people go, oh yeah, space junk, it's a problem. But I liked the fact that our podcast, our guest on that podcast is Mark Brown, a former astronaut who is leading the efforts of the Association of Space Explorers, which is basically in this association, if you've been into space and gone around the Earth once, you can be a member. And we sort of joke around about that, but we really take our sort of unique perspective seriously, and in that there's things that we've seen and done that make us realize that things like space debris and things like asteroids, they are not going to know some country line, some border in between places. Right. These are Earth problems. I'm a long answer. I'm sorry, Beth.
No, it's fine. Absolutely. No, please. I am so thrilled that you were here and to talk to you, but we're going to take a quick break for one last commercial. And then I will be back, and I want to ask you some more about your experiences in space and your musicianship. So we'll be right back, everybody. Stay tuned. Welcome back, everyone. Once again, I am joined by Dr. Cady Coleman, a former astronaut and musician, and the new co-host of a brand new podcast called Mission Interplanetary. Thank you again for joining us, Cady. We've talked about the podcast, and I'm very excited about that, and everybody should go take a listen. It is a really good podcast, and it only started in March, so you haven't missed a lot. It's weekly. Take a listen. But I want to talk to you because you're the first astronaut I've gotten to directly interview. You are not the first one I have met, but I get to interview you. So I want to know what was it like? And it's not just this generic, what was it like in space? But that moment when you realize that first space shuttle mission, when you are up there and you are looking back, what goes through your head?
It is that first glance out the window where you actually see the curve of the Earth. And it's just so clear in this visceral way that you are in a spaceship in orbit around the Earth. And just like you were supposed to be, but I think it's hard for a human to really take in that that's really going to happen. And I think it's a view that really changes you, in that you can't unsee it. It's just going to be there. That, it's hard to think that it's important which exact place. It may be really nice and something you like to think about, the exact place you come from on the Earth and how proud you are and how much you love the community there. But in terms of really what's real, we're all from the same place. We are all from the spaceship Earth. And that the same things that happen on a space crew, where it's just really clear to us that the mission is more important than whether we wish each other was different or we were going home, because the mission is just so important. I think that that's the spirit that we need to have on spaceship Earth to meet a lot of the challenges that we have here.
I love that sentiment. So your podcast focuses primarily on how we get people to space, essentially, not just this elite astronaut corps, but how we get more people involved in space and how we bring that to people. What do you see the future of our sort of space travel, space tourism? What do you see as the future of all of that right now?
Ellen Stofan says something in actually episode that's this week, she was the director of the Air and Space Museum, and now she's like in charge of all science at the Smithsonian. And she said, we're on the cusp of having more and more humans in space. And there's nothing, you're not going to sit on a cusp and be there. That's something that is really, it's a moving thing. We are suddenly going to have a lot of people who've been to space. And, already the fact that, we've gone from having the Mercury 7 to this really diverse group of people, not diverse enough, of course. But each of us brings our own kind of humanity up there. And I think it is that bit of humanity. And also, every one of us that ends up, we have our picture taken or we speak our mind on a podcast, there's people that sort of see and hear that and it resonates with them, whether I think it really, in some, I don't know if they always think about it, but it just makes a little note in their heads like, hey, people like me belong there because it belongs to all of us. Space does. And so I'm excited about more and more people going. And, there'll be people that are different than me, people that are the same as me. And it's just nice to have so many more.
I like that. So everybody kind of, when they talk about your bio, they always bring up the fact that you are a musician, you play the flute, and you have done so in some really unusual circumstances. So everybody, I noticed that it's always about Jethro Tull, which is great. Is that the only thing that you look back at as a highlight of some of that? Or are there other performances that you've done on the space station or here even on Earth that have been meaningful to you?
Well, it's funny. I can speak in front of an audience. I've done that in my NASA career, all those kinds of things. But and up on the space station, it's just easy to think, oh, well, it's just me, right? And hopefully the editor will figure something out to do with this, right? But then when you do this on a stage in front of people, that is a hard thing. That is a scary thing to me. But I've been actually really happy that, sort of part of my human side is to play music. And when you say I'm a musician, I'm thinking, well, I play music. Because, it's not like I practice enough, right? But I do love music and I love to play with people. And that was for me.
Now, see, I think that makes you a musician. So we're just going to continue to go with that. You are an astronaut and a musician.
But I did love, I think I tell people, I think it takes some bravery, to say, hello, Ian Anderson, you don't know me. You don't know if I can play or not, but I'd like to bring your flute up to space. And yes, people will pay attention. So can we do something that kind of makes some ripples that moves everybody forward? And I did that same thing with, I brought an Irish flute for the chieftains and a tin whistle up there. And then I also brought my own flute, but I brought 2/3 of my flute. Like I have the flute's in 3 pieces, and the company that made my flute, I brought their mouthpiece and the rest of my flute, and I gave that back to them. We traded back when I got home, and it goes in this like flute mobile that goes around the country, and even a beginning flute player can play the flute that went 93 million miles and went to space.
That is amazing. So that is something that when pandemic times are over, everybody should look for that opportunity. So Cady, as we wrap up here, what are some final thoughts you have on the importance of space for all of us?
When I got to go, I always used to think that, I'm on Earth and I'm going to go to space and it's like going somewhere else. And then when I got there, I realized that, I still felt like the same person. And, home is still there. I'm just not exactly there. Kind of like for me as a commuter when I'm in Houston and home is in Massachusetts, I could still have a sense of home. And so really, I just felt like space, and Earth are just bigger than we thought. The place that we live, the place that we call home as humans. And I think everyone belongs there. And at the same time, as we expand further and we go, we're looking to settle, on the moon and to settle on Mars, we have the opportunity to do some redoing, to not do things exactly the same way, to put some thought into who gets to decide, who gets to go, and how do we make decisions together. And that's actually what the podcast is about, is with everybody becoming, interplanetary, how are we really going to do that? And I think the details are pretty fascinating.
I am really enjoying your new podcast, and I again recommend everybody go listen to it. Mission Planetary can be found on basically any of your local podcast services, same as Daily Space. So please go check both of us out. And thank you again, Dr. Coleman, for joining us. This has been wonderful.
I like yours as well. I'm an astronaut, but I don't especially know astrophysics or astronomy as much as I would like. And I like the way you explain things. I like when you help me look at the night sky, like you explain it in a way that I'm really going to be able to go out and look. And that's very meaningful to me because, it's hard to know everything. So it's nice when people teach you.
Thank you. Thank you.
Thanks.
Yep. All right. For now, this has been the Daily Space.
You can find more information on all our stories, including images, at dailyspace.org. As always, we're here thanks to your donations. If you like our content, please consider joining our Patreon at patreon.com/CosmoQuestX.